Hi everyone, we are beginning week 4 here talking about the surface area of pyramids. So what I need you to do is take a moment to read over this warm-up section. It talks all about some information about pyramids, particularly regular pyramids as well. So take a moment to pause the video and read over that. Now, one of the biggest things we need to talk about here is the difference between the height of the pyramid and the slant height of the pyramid. Now, notice the height is coming in here from the vertex to the base, while the slant height is moving down one of the lateral faces of our pyramid here in green. So there is a difference between the height from the vertex to the base of our regular pyramids and our slant height. That's important today because as we start talking about the surface area of our pyramids, we need to use the slant height in these problems. Okay, so again, we're going to be using slant height in order to find these. Now, when we talk about perimeter, that's going to be of the base shape, and then big B is also going to be the area of your base shape. So again, these are basically our three components we need to find today. And in order to be successful, each time we're going to want to draw a picture of the base, find its perimeter, its area, identify what the slant height is, and plug it into our formula. Okay, so for our first example here, notice our base this time is a square. Why do we know it is a square? Well, it's telling us that these sides are congruent, so we can assume those opposite sides are also congruent. So we have this base square here, and all four sides are 4, which means the perimeter of this base is going to be 4 plus 4 plus 4 plus 4, or 16. And the area of the base is going to be 4 times 4, which is also 16. Right, the difference would be units versus units squared. Okay. Now, the slant height is being given this time. Our slant height is coming right here, and it is 8 centimeters. And in order then to find the lateral area, we need to take 1/2 the perimeter of the base times that slant height. So half of 16 times 8 is going to be 64 square centimeters. And then for our total surface area, it's going to be that lateral area plus the one base that we have area. So in this case, 64 was our lateral area. Area of the base we said is 16. So 64 plus 16, 80 square centimeters. Okay, so here are our two answers. Now, as we move on to the next page, we have another example of a square pyramid with a really similar picture setup going for it. So take a moment on your own to pause the video and check what is the perimeter of the base, the area of the base, and the slant height, and then calculate your lateral area and total surface area. Now again, you should have noticed that this base of our pyramid is a square again, with all 4 sides coming to be 9. So the perimeter of the base, we are adding up 9 4 times. So we have a total perimeter of 36 feet. Area of the base is 9 times 9, so 81 times width. And our slant height this time is given as 12.1. So total lateral area, 1/2, oops, underneath that, is 1/2 perimeter of the base times the slant height for a total of 217.8 feet squared. And our total surface area then is the lateral area plus that area of the base. So the 217.8 plus the 81 for a total of 298.8 square feet. Okay. Now, the next piece of this looks really similar to examples A and example B. Okay, you're probably thinking, okay, this is another square pyramid base. That's good to know. The perimeter of this base then is going to be found by adding up all four sides. So 6 plus 6 plus 6 plus 6 is a total of 24. The area of the base, length times width here, 6 times 6 is 36. What we have a problem with, though, this time is the slant height, okay? Because when we try to write our slant height this time, we don't have it. What we're being given is the height is 5 from vertex to base. We don't have the slant height. So we need to take a moment to sidestep and find what the heck is our slant height given that our height is 5. Now another thing to notice here is the base of this triangle is not 6. Okay, it is not the full side length of our pyramid. Our full pyramid side length is 6. We are only taking half of that, so 3. So as we solve for our slant height, we need to use Pythagorean theorem to find that slant height because that's the hypotenuse of this right triangle. So our hypotenuse squared equals 5 squared plus 3 squared. So 25 plus 9, L squared equals 34. So if we square root 34, get about 5.8. So our slant height is 5.8. Now from there, to find the lateral area, LA, we know it's 1/2 the perimeter of the base times that slant height. So half of 24 times 5.8 is going to give us about 69.6 square centimeters. And then our total surface area is the lateral area plus the area of the base, which we said from up above was 36. So 69.6 plus 36, 105.6 square centimeters. All right, now as we move on to page 3 then of the notes, again, notice example D is extremely similar to example C. So on your own, look for the perimeter of the base, the area of the base, and the slant height before calculating then the total lateral area and total surface area. Pause the video now to do that. Now as we start here, again, we have that square base. Okay, so that square base has 4 sides that are all equal 4. So the perimeter we said is going to be 16 feet. The area of the base is going to be 4 times 4, so 16 square feet. And then from there, we talked about in that last problem that in order to calculate this slant height, we need to use Pythagorean theorem. Again, your base of your triangle is half of this side length. They are not equal. So in order to find L squared, we need to take 6 squared plus 2 squared. So L squared is going to equal this, is going to equal 40. And when we square root that, the square root of 40 is about 6.3. So that's going to be our slant height this time, 6.3. Now, finally, the lateral area is 1/2 perimeter of the base times that slant height for a total this time of 50.4 feet squared. And last but not least, the surface area is that total lateral area plus the area of our base. So we end up with 66.4 square feet. All right. Next example here, notice we have a composite figure here. And we have a cube with a pyramid stacked on top of it. Now, if we want to wrap this up and give it to someone as a gift, when we use wrapping paper, we are only going to cover the surface, right? You're wrapping the outside. You only are going to wrap everything you can touch. So what this means is we are only going to be looking at not the total surface area, but pieces of the total surface area. What I mean by that is if we're wrapping this pyramid, notice the base of this pyramid isn't on the surface. So really when we're looking at the pyramid, we're only going to be trying to find the lateral area of the pyramid. And for the cube, again, that top base here is not able to be touched. So when we find the surface area of the cube, the surface area isn't going to be the total lateral area plus 2 bases. We only can touch 1 base. So that's where the modification is going to come here. It would only be 1 base. Now, when we talk about the pyramid, going back to what we talked about up above, we want to look at the base and notice the base is going to have sides that are all 6 this time around. That's square base. So the perimeter of that base is adding up 6 4 times, so 24. And the area of that base is going to be 36. The slant height, we were lucky enough to be given here. You don't have to use any Pythagorean theorem to find it. It is 5. So as we look for this lateral area, it's 1/2 the perimeter of the base times that slant height. So we end up with 60 square inches to cover. Now for the cube, again, we talked about we had to modify a little bit that surface area because we only have 1 base to cover. The lateral area of our cube, or the prism here, reminder, lateral area is the perimeter of the base times the height of the prism. Well, lucky for us, the perimeter of the base is the same in our prism as it was our pyramid. So we can use the same perimeter here that we used up above. That perimeter was 24 since they share the same base. Now the height here is referring to the height of our prism, the height of the cube, which is 6. And again, lucky for us, the area of the base is the same for both the pyramid and that prism, right? They both have that base that is 36 for the area. So our total area then for the cube is going to be 180 square inches. And finally, the total composite area is going to be found by taking the 60 inches we had up above plus the 180 for a total then of 240 square inches. It's a little bit of work on that guy. All right, our last example of the day then is talking about example 3 here. Now, as we move to example 3, it is really similar to the last problem. We have the pyramid that we only want the lateral area of, because we can only touch its lateral area, the base is hidden. And for the prism, the cube, we want the lateral area that we can touch plus the one base that is being exposed. Okay, so just like last problem, we need the lateral area of the pyramid and then lateral area plus a base for the prism. Okay, so take a moment to calculate for our pyramid what is the perimeter of the base and the area of the base and our slant height. Well, for both our prism and our pyramid, they have the same base, right? Notice all four sides around it are going to be 4. So when we talk about for both the prism and the pyramid, the perimeter of the base is 16. After we add up 4 times, area of the base is also 16 because 4 times 4 is 16. The slant height then for our pyramid, we have to be careful about. Notice, I should write it up here. The slant height is given, but they're also trying to be tricksy and give you the height of the pyramid. We don't care about the height of the pyramid. We care about the slant height of the pyramid when it comes to lateral area. So for this pyramid, in order to find the lateral area, it's 1/2 the perimeter of the base times the slant height of 3 for a total then of 24 square feet. Now the prism needs to take the lateral area, aka the perimeter of the base times the height of the prism, and add to it that area of the base. Well, same perimeter of the base as it was for the pyramid. The height this time, be very careful, is the height of the prism, which is 5 feet. And the area of the base again is the same as it was for pyramid. So 16 times 5 plus 16 is a total of 96 square feet. Now, in order to find the total area, what are we going to have to do? Well, in order to find that total area, we're going to add together those two answers that we got for a combined total of 120 square feet. All right, now at the very last bit here for closure, on combination steps, how do you know when to add or what to subtract or not include in your calculation? Again, if you cannot touch the bases, especially the bases seem to be, you do not include them. Okay, so only the exposed surfaces that we can touch get included. So for example, up above we only had 1 base instead of 2. So you only want to think about what is exposed here for me to actually be able to touch. Thanks everyone.